Hi everyone, today I'm going to talk about the question, found the max path sum of a binary tree of one leaf node to another leaf node. And for this question, we will do some clarification. The input type for this question is going to be a chain node. We're going to put a chain node root into it. And the output type going to be a integer, which is the founded max path sum value of this tree. And the assumption for this question, we assume there are going to be some negative value in this tree, and if we have the root with a null value, we just return a 0. And for this question, I'm going to use a recursion way to solve it. Inside the function, I will need to maintain a global max to storage every the current max value, and also analyze two cases for this question. So when the root have both left child and the right child, we will need to update the global max if necessary, and also return the best path sum from either left side or the right side, plus the root key to the caller. In another case, if the root key doesn't have left side or right side, or neither don't have any of the trial node, just return the non-null value plus the root key to the caller. So let's write the code for this question. Okay. So for the public function, the output type going to be a integer, and we name it max path. The input type is a chain node root, like we just assumed in the sanity check. If the root is null, just return 0 to the caller. And we want to maintain a max value, which gonna be a int array, and we're gonna return the first element of this int array. So let's new a int array, initialize this value to a integer main value. And we need to use a helper function to do the recursion call. We will put root value and the max variable into it. As a result, we're gonna return the first element, which is an integer, to the caller. Okay, so now let's look at the private function, which gonna also have a output value integer. That means the best path sum of every for every node, and this is called helper. Input type gonna be the original root and int array max. So in this recursive function, the base case for this recursive function is the smaller size for this function, which is the last node need to call the function. So the last node is, if the last node root is null, we will return 0. And we also need to, I also need to maintain two variable left and right in here. They means the best path sum from the left child node and the best path sum from the right child node. So we're gonna need to call the function again in here. Integer left gonna be the left child of root left with max, and the integer right gonna be the best path sum of root right. Okay, and let's analyze two cases. So when we can update the global max, when the node is a leaf node. So if the node is a leaf node, the node should have both left child and the right child. So in this case, case 1, we will have a root dot left not equals to null, at the same time root dot right not equals to null. Okay, update global max if necessary. So if the left value plus right value plus root current key value is bigger than max, update it. Okay, update it to left plus right plus root key. Okay, and under this condition, we should return the best path of either side. So we will get max left or right plus root key. Okay, this is case one. The current node have both left child and right child. So in case two, the current nodes don't have left child or don't have right child or don't have any child. We just need to return the non-NOR value. So if the root left is NOR, we need to return right value plus root key, or if the left value is not NOR, we just return the left plus root key. Okay. Okay, this is the code part. Let's do a small test for this test. So we got the tree node -1, -2, 3, 4, and 5, and we're supposed to return 3 plus 4 plus 5. The answer gonna be 12. So if we put -1 into the function here, and we call the recursive function multiple times, we should get left best value -2 and the right best value 12. At the same time, it got updated. So the best path root from right side gonna be like all 3 nodes. And in case one, we don't update. In case one, it is a valid root, but we don't update the max here and return the best to the color. And we don't need case two for this special case. And after the function, we should return the first element of this int array, which is 12. Okay. For the time and space complexity, the time complexity for this question is we have to call function for every single node, and each time we call function cost a O1 time. So together is a ON time together. The space complexity, we will need for this recursive function, we will need a max steps of call stack function. So in total is O height time on stack side. And we haven't used any extra space for the heap side. So together is 2 O height. Okay. All right. Thank you. This is the question for from the max path sum of a binary tree. Let me know if you have any follow-up questions.